Yes, we're here today with Andrew Hulse, who is Vice President of Sales and Business Development at Sage Glass, makers of electrochromic glass for buildings. The glass tints on demand and has some other features. Uh, Glad to meet you, Andrew Hulse.
Nice to meet you as well.
And can you tell us about Sage Electrochromic Glass and how government facilities can benefit from this product?
Yeah, absolutely. So what Sage Electrochromatic Glass is, Sage Glass, is it's electronically tintable glass. And it not only blocks the light coming into the space, but it also controls the amount of solar gain coming into the space because it controls both the infrared as well as the ultraviolet spectrum as well. So when you put Sage Glass in a building, and then you tie it in through our control systems, what you're able to do is able to regulate and control the amount of light and heat that you allow into a building. And you can do this in such a way because we can zone it that you can actually maximize the daylight in the space because you can have certain areas cleared out to throw more light into the core of the building, while at the same time having other zones tinted to be able to block that unwanted heat gain and glare and make the space more comfortable, more productive, but still maximize the daylight in the space.
And I know you folks have installed uh, your product in GSA facilities and state and local governments.
Yeah, that's absolutely true. So, for example, we are the skylight application in the new GSA headquarters atrium in Washington D.C. On the National Mall. In addition to that, we've been installed in other government applications such as skylight at the Naval Academy. Done some curtain wall applications in some local municipalities. Also part of the Green Proving Ground projects as well. So we've done a number of government installations at both the state, local, and national levels.
And Andrew, looking at your website, I see your product can help reduce fading in carpeting, furnishings. Uh, that's another benefit.
Yeah, absolutely. So when you think about the total life cycle of the building itself, you're concerned about the heat gain coming into space because that affects the amount of cold air that you have to throw at the space. You're concerned about glare because you want the employees to be productive in their space, be able to see their screens and those sort of things. But there's a third aspect around ultraviolet and fading protection. And if you're able to manage the ultraviolet light coming into the space, as well as the rest of the spectrum, because there's more of the spectrum affects fading than just ultraviolet. But that being said, it can help extend the life of those items that are in that space as well. So once again, that provides a much more comfortable space and a more sustainable space as well. What's interesting, and one thing I should mention is that we're able to do this in a way that in today's dollars is really cost neutral to the first cost construction cost of the building. A lot of people perceive something like electrochromics as being, very expensive, and it is more expensive than just glass. But the fact is, we can replace other technologies and other devices that are being used for solar control today. So because we're able to get down to about a 1% visible light transmission, we can eliminate the need for things like blinds and shades, motorized blinds and shades, external sunshades, those devices that are being used in addition to the glass to manage the solar control solution. So you collapse that solar control solution into the glass. And while the installed cost of our glass versus normal low E glass, for example, will be more expensive, when you start eliminating those other devices, which happen to be in other parts of the building construction package, so you have to do some math around that, the glass ends up being close to first cost neutral.
And I'm sure this product can have applications in retrofits as well, not just new construction.
Yeah, that's true. We've done, traditionally about half of our projects have been retrofit applications. Now, you still end up replacing the glass, so the framing systems would have to be appropriate for our systems, et cetera. But as I said, in about half of the installations that we've done, they've been retrofits, and the reason is that when people get into some of these buildings where they have large spans of glass that allow all of this heat gain in, they realize that they just can't live with that with that heat gain and glare, and so they need something to be able to mitigate that.
Do you folks have any estimate how much energy savings is achievable with this product?
Yeah, absolutely. So obviously it varies widely depending on how the application is put together, the amount of glass and those sort of things. But as a rule of thumb, the studies that we've seen, both third-party studies as well as our own, generally what we're seeing is about a 20% energy reduction on the operating costs of the building. We see about a 25 to 30% peak demand reduction. And of course, that peak demand reduction is important because that drives down the energy costs associated with those peak demand times. And then we also, when we're incorporated with from a daylighting perspective, depending on what we're being compared to, can drive up to about a 60% energy savings on lighting costs. So, it varies based on what the comparisons are, but pretty strong energy savings.
Uh, the fact this product does it block out UV rays? Could that be a health benefit?
Uh, I think from that perspective, we're more focused on from the UV side of things on fading protection and those sort of things. And of course, we have some additional protection as well when it comes to the fact that that our device has a laminated outboard light that adds some additional protection from UV as well. But in addition to that, from a safety perspective, the fact that our glass is laminated on the outboard light, that provides additional safety protection as well.
This is very helpful, Andrew. Do you see more government facilities installing this electrochromic glass in 2014?
Yeah, absolutely. We've got a number of different facilities that are currently in process or in the final stages of design that are very interested in use of the technology. As I stated earlier, what's neat about it is that we're able to collapse that solar control solution into the glass itself, and then as opposed to things like blinds and shades, where you have to close the blinds and shades and you shut that facility off from the outdoors. Even when fully tinted, SageGlass still maintains that viewing connection to the outdoors. So even when you're down to about a 1% visible light transmission, you can still see outside. You still maintain that view and connection. And obviously, as we work, learn, and heal in buildings, having that viewing connection to the outdoors does have significant positive outcomes.
And Andrew, last question. Do you have any advice for government facility managers who are thinking of specifying electrochromic glass in their building construction and retrofits?
Yeah, absolutely. So the first thing that I would recommend is get us involved early in the design. There's a number of ways that we can help guide the design that will help minimize the cost, the installed cost of the glazing when it is being used. And for example, we can do things like make suggestions around combining sizes or minimizing shapes and those sort of things to really make it the most efficient use of the glass as possible. So the earlier we're involved in the design, the more work we can do with the project manager to really maximize the impact of the glass and minimize the cost.
This is very helpful. We've been here today with Andrew Hulse, who is Vice President of Sales and Business Development at SageGlass, makers of electrochromic glass for buildings. You can read more about SageGlass in the pages of Government Product News magazine. And again, I'm Mike Keating.
And I'm Andrew Hulse. Thank you very much.
Thank you, Andrew.